All right, we have been talking about bivariate data, meaning two variables. We've also been talking about scatter plots and how we can plot this data onto what's called a scatter plot, onto a coordinate grid. And if you look at the first graph I have here, height versus arm span, we can see that this data closely matches a line. And because it closely matches a line, we can draw what's called a line of best fit. And this line of best fit kind of matches the trend of the data. And we would call this graph, we would say that this graph has positive linear association because it strongly matches a line when we graph it. And then the graph on the right here, it definitely has a pattern, but it's not a linear pattern. This one on the right, okay, it kind of matches this U shape. It's called a parabola, height of ball in the air versus time. So if we go ahead and in the text box, we could go ahead and describe this association as non-linear association. And then the next two plots here down below, the one on the right clearly has negative linear association. So we can model this data with a line of best fit. And we would describe the association between movie attendance and time waiting in line as negative linear association. Now here on the left, there's no pattern here between money and time. So we would call this having no association. Now the next kind of task that we like to take is after we match a line, a linear line of best fit to a set of data, then we like to write the equation for that line. So make this a little thicker. All right, so here's a nice line of best fit for this this situation where we've got percent of total sales coming from the internet versus years. We need to, like all linear equations, we need to write it in our format y equals mx plus b. So our b, our y-intercept, comes from right here on the y-axis. That's our b value of 35. So here we would define our b value to be 35. And then we can pick any sort of points we want that kind of closely match the data. I'm going to go from 40 to 50 and then over. So up 40 to 50. And then we're going to head over to see where this hits our line again. And this is what's called our slope triangle. So we've got a change in y of 10, a change in x of 1, 2, 3, 4 years. So my slope m is change in y divided by change in x, 10 divided by 4. 10 divided by 4 is 2.5. So then I can go ahead and write the equation y equals 2.5 x plus 35. So my graph here is kind of starting in 2003. So in 2003, we would have 35% of the book sales from the internet. And then my X would be every year after that. So if I want to know 2013, I could plug in 10 here, and then we could go ahead and solve that equation. So this is my line of best fit, and we can go ahead and match that with a linear equation.